Goa, a land of charming beaches and luscious landscape. Some beautiful paths can't be discovered without letting your imaginations flow. Let the ideas come alive. Presenting to you National Institute of Technology Goa. NIT Goa is one of the 10 NITs established under the aegis of MHRD in 2010. Currently, the institute works from its transit campus in Farmagudi. There are 5 engineering disciplines: computer science and engineering, electronics and communication engineering, electrical and electronics engineering, civil engineering, and mechanical engineering. The institute also has Department of Applied Sciences and Department of Humanities and Social Sciences.
The Computer Science and Engineering Department has 3 computer laboratories equipped with softwares for the UG and PG programs. The Department of Electrical and Electronics Engineering has 2 laboratories with computational facilities where students can perform numerical simulations and also real-time simulations.
The Department of Electronics and Communication has 2 labs equipped with antenna and microwave test benches and industry standard tools like Xilinx, Cadence, Mentor Graphics and Silvaco software. Within 9 years of its inception, NIT Goa has been ranked among the engineering colleges in India by National Institutional Ranking Framework, also known as NIRF.
The campus has 4 hostels with 24-hour Wi-Fi and facilities for recreational activities. It's a home away from home.
The institute has a library that has more than 8,000 books and publications with 24/7 access to e-journals. As a part of Unnat Bharat Abhiyan launched by MHRD, NIT Goa has adopted 5 villages. NIT Goa.
Hi, good afternoon to everybody. This is Shanti, Assistant Professor of Department of Mechanical Engineering, NIT Goa. I, on behalf of Department of Mechanical Engineering, NIT Goa, welcomes you to this webinar session on CAD CAM and CNC programming. We all know that knowledge of manufacturing is important to manufacture a product. In manufacturing, we convert raw material into finished product by adding value to it by various manufacturing processes. This is a tedious process, involves lot of time. In order to sustain in a global market, the product which we make should be take less time to produce it, and the cost involved to make the product also less. The era of digital manufacturing helps to resolve this issue. In digital manufacturing, powerful computer equipped with software helps to manufacture the product. The softwares like the CAD CAM softwares helps a designer to design a product and manufacture the product, especially the CNC machining. So in CAD, we design a model of the product, and in CAM, the model which we have created in CAD is used, and we convert into a physical part by stimulating into a actual manufacturing process. So this is done by using the CNC programming. So now I welcome Nitin Vakodi, Director mastercam of Deccan IT Technologies, to explain about this thing. Welcome you, sir. Thank you.
Good afternoon, everyone. Let me introduce you to Mr. Nitin Vakode, Director of Deccan IT Technologies, Skyline. He has completed his graduation in BE Production Engineering, post-graduation in ME Mechanical with specialization, PhD in pursuing in CNC machining parameters optimization area. Areas of experience: Industry 4.0, robotics, CNC manufacturing, product design and tooling development, stimulation. Total industrial experience is of 24 years, 2 years as a director with Deccan IT Technologies, Skylip Technologies, 13 years, that is to July 2005 to April 2018 with Onwards Technology Limited, Associate Vice President PSG. 8 years, that is August 1997 to July 2005 experience, German tool room Aurangabad in German precision and tooling manufacturing. 1 year, that is July 1996 to July 1997 with Aditya Birla Group, CNC manufacturing in hardcore expertise in CNC, programming and manufacturing, CNC milling, 2 to 5 axis milling, turning, mastercam programming, CAD, CAM and CAE, knowledge about cutting tools and its parameters, CNC controller programming, programming for various machines like DMG, HAAS, Fager, Thermwood, BFW, Jyoti, Okuma, Mitsubishi. Metrology CMM expert, domain expertise in plastic mold manufacturing, sheet metal dies, casting dies, component development, robot programming, expertise in executing CAM projects using mastercam, UG, NX, CAD and CAM, Vericut, CATIA V5s, SolidWorks, NC, CMU. International exposure for business, seminars, training in USA, Germany, Italy, UAE, Sri Lanka, Saudi Arabia, Qatar and Malaysia. As extracurricular activity to support academic, actively involved in providing technical lectures, training, curriculum development, CAD, CAM and CAE manufacturing with Indo-German tool room, CITD, GTTC. Supported Board of Studies, Savitribai Phule University, industry member, Raisoni College of Engineering, Waguri, Pune, BOS member, Vishwakarma University, Pune Management Studies and BOS member. Certifications in plastics and mold design, certification GTZ Germany, CMM inspection, Carl Zeiss 6-week training, SolidWorks certification, AVA certification, Vericut certified to iOS auditor. Thank you.
Thank you. Thank you for introducing. Thank you, ma'am, Shanti, ma'am. So now I would like to start with the technical session. Before that, we'll just like to have some background of what we are going to do today. So you might have seen the complex part which are moving in front of you. Those are parts of maybe sometimes aerospace, some turbo machineries, sometimes some automotive parts, some shipping parts, different parts. But if you see the change over a period of decades, there is a huge change in the customer requirements, hence the product development scenario is totally changed. So due to that, there is a lot of pressure on manufacturing teams. So what is required by a customer is being thrown or designed by designers and now thrown to the manufacturers. So what made it the change? If you see 20 years back, the car or two-wheeler or any product was designed to a very good factor of safety. So 1 minute. So the the product was designed in such a way that manufacturing was very very easy. Even the designs were so simple, box types or a circular type, or which are very simple in shapes. So if you take a case of Ambassador or maybe a Premier Padmini or similar Bajaj auto scooters those days, so the shapes were so simple. So customer test was not considered. What the manufacturer were manufacturing or auto companies were developing, the same thing was given to the customer, because there was a demand was huge and the supply was low. But now we have so many manufacturers, automotive if you take, so many number of car manufacturers you will find, so many number of two-wheeler manufacturers you will find. So there is a competition. So competition has risen the price costing competition as well. So that has made them to reduce the cost. So what will they do? So they have started reducing the thickness of the sheet metal, or started reducing the part complexities, making it a little bit of cost friendly. So that has made a lot of challenges on the designers and then on the manufacturers. So at the same time, when you say that the simple design or simple shapes to the complex shapes, the cars today are of great shape, great styling. So those require a good CAD CAM software to manufacture that on CNC machine. So the CNC machines are also not the old way. Those are very complex CNC machines which are able to use rotary tables for 4 and 5 axis machining. There are multitasking machines. So these various new technology has been introduced. So many of you will have a question that if I'm a mechanical engineering, I have a lot of not intended to go to manufacturing, I'm intended to go to the design, then why should I understand the manufacturing? So friends, if you have understand or gone through a concept of DFX, DFX is nothing but the X stands for multiple things: design for aesthetics, design for manufacturing, design for assembly, design for so many including the disposals, and so many things are there. So one of that manufacturing is very very crucial. So let's say you design something which is not manufacturable. So whether it will be able to manufacture and get it supplied to the market? No. So if a designer don't know how it is going to be manufactured, how will he design properly as per the requirement of manufacturing? So even if you are trying or thinking of moving to the design career or maybe a CAE career, so you should have a manufacturability understanding, because many a time CAE people suggest CAD team that because of such and such things, please alter this so that the strength will be better. But if you don't have understanding, if this change can make it non-manufacturable, so he will not make that suggestion, because then again there will be forward reverse iterations which will make it a lot of time. And today, one day delay in launching a product makes a lot of difference to the companies. Okay, so we will see the live part of software also, how the software works. Okay, and before that I'll just show you a small history of the software, how it is developed, and then we will move to the actual operations. Okay.
parts that we did, we were taking old programs that we were running for years and changing them from 40 minutes to, in some cases, 22 minutes. Almost a 50% increase right off the bat.
The biggest problem we got right now in roughing out these billet blocks is the chip conveyor won't keep up.
Biggest reason we use mastercam? Flexibility. You wouldn't believe what the energy industry can throw at us.
What used to take the clinician 8 to 12 hours, now we're using mastercam to turn that time around into 1 or 2 hours.
Hello. Yeah, so we'll be going through a small presentation and then see the actual software. And Yeah. So here, this is Deccan IT Technologies, which are authorized result of mastercam in India. And mastercam, as you already seen, it's a CNC software incorporation software. And you can see that the cutter is cutting across the globe. The reason is mastercam is being used almost in every country across the globe. That's the reason the denotation is the cutter cutting across the globe. So with the introduction and this information, you might have gone through or understood to some extent, like how CAD CAM can help you produce the parts with a better quality, better shapes, and as per the requirements. That's the reason that the programmers with the mastercam programming skills are high in demand in the United States as well as Japan, Australia, in Europe as well. So here you can cut almost all sort of parts which are required by the designers using the different kind of machines, and there are different technologies which can help you use the best applications. Okay. There are certain users who are still using conventional machining, but with the introduction of Industry 4.0 digital era, because now the factories are interconnected. One factory manufacturing some parts in Malaysia, some part in Germany, or some part in Hartford in USA, or some other part. So what happens? These all are expected to share data live because of the Industry 4.0. So because of that, the CAD CAM has become a very important part in the manufacturing link. So earlier people were used to skip it or to do it very on a conventional machines or CNC machine, but programming conventionally. So that was used to happen, but now even the machine inspections are happening online on machine with the probing, programming, and all that. So that has changed a lot of things. So now you can eliminate costly mistakes. You can save a lot of material and getting a precision components. So there are multiple benefits of using CAD CAM. So here again, what exactly it does. So you can design parts on mastercam, but it's not like a high-end CAD software like maybe Creo or CATIA, okay? Because it's designed for manufacturing. It's a mastercam, so it has the design features which are suitable for the manufacturer or a programmer to design certain clamps or a fixture or do small simple parts. Okay. Milling, there is a 2D 3D milling operations are available. XYZ, XZ axis CNC turning is there, C axis is there, XYZ turning is also available. Machines with the turret with the milling capabilities. Multi-axis machines are there. Viridium, multi-axis, the machine which is in front of you is a multi-axis machine which has got a rotary axis as a C axis and A axis. So when you want to cut a complex part like the one which is shown there, which require tool axis to be aligned, continuous, simultaneously, different directions, axis directions. So that requires this such kind of a parts. Even the impeller, which you have seen there, turbo machinery part, which also requires simultaneous 5 axis. If you see in your Salicet Goa, MacBorot Engineering, so they are our customers. They are using for the turbo machineries. So they are using simultaneous 5-axis machining. They are using for turning. They are using for normal 3-axis machining. So they are doing best of its application. If you ever want to have a look at it, maybe you can request them, or I can also check with them if they can allow certain areas to be seen. So that will be of a great value to them. Here you can see that Viridium. Viridium is a non-conventional sort of machining. You might have learned EDM, so it's similar to EDM but with the wire. So it's a thin wire of 0.1 to 0.25 with a dielectric medium of there is a demineralized water or certain fluids, chemicalized fluids, which are flushed, used as a jet, and the wire on upper guide and lower guide is kept at a little bit of tension and with the electric power in it. So because of the sparking between the part and the wire, it erodes the material at very high temperature zone. So wire cutting happens and you get a profile which can be used for maybe press tool dies, or piercing dies, or different shearing dies and all such profiles which are cut with the wire radium, wire of 0.1 to 0.25 millimeter diameter. You can see next is a router. Router is almost same as a milling machine, but used more into the sheets type of cutting. So like if you take a case of aircraft structure, so all around shell is required to be cut in a proper shapes with different cutouts. So all such parts, even internal interiors, require a lot of router cuttings. Shipbuilding industry require a lot of router cuttings. Even the automotive parts require a lot of router. So router is nothing but a milling, but with certain specific angular heads are there, certain tabs are there in order to cut the sheet metals properly. There is a nesting. Nesting will help you utilize the sheet in a best possible way. With keeping one part, I want one part to be cut from 1 meter by 1 meter with the maximum utilization of material. So it will arrange the part in such a way that maximum material utilization will be there. So that is a router actually. Design, as I mentioned, like it has a features intended for the programmer for ease of manufacturing, for making certain clamps, certain things. But one good part of it is that it has a very good number of this one CAD model importers, translator you can call it. So it has got a solid edge, Creo, it has got Step, Parasolid, IGS, DXF, DWG, STL. So many sort of CAD translators are there. So students who want to do any project from any company, they can easily ask the yeah, please give us, send us a part, we'll do. Otherwise it is always forward backward exercise. Hello. I think there is a stuck up slide on the this one. Okay, I will use yeah. Right. So milling, as we discussed, here I think you was not able to see this one where I shown the multi-axis machine with a rotary table, rotary axis C, and this one. Here I spoke about the solid, and then we are on to the milling. So milling, as we have seen, it's intended for prismatic parts machining earlier, but now it's all complex parts can be machined: turbine blades, dyno mold, cavities, aerospace components, defense sector components. If you take a case of like all ISROs, they are using, all HLs are using, DRDO, DRDL, Bharat Dynamics Limited, which manufactures the missiles for us. They are all using mastercam for programming. Here it has got a various features. You can have a standard libraries for the tool parameters. You have simulation facilities. Parameters easily you can make changes as per the requirement. So it's user friendly in terms of interface as well as the features. I'll show you a small video of milling, which you might have seen in your maybe workshop, where your CNC machine must be there. This is basically kind of a high efficiency machining. Hello. Yeah, so it is helically entering, reaching to a depth of cut, and then machining. The technology is evolving so fast that high-speed machining is now moved into high-efficiency machining. Now you see this video, and then there is another video, maybe if I am possible I will try to show you. So there helical ramping happens up to the maybe 15 to 20 millimeter depth of cut gradually, and then at one time it can take a depth of cut of 30 millimeter, and the cutting is also very smooth. So now here also you can see that now it is cutting the complete depth. Earlier similar type of machining would take around 30 or some odd minutes, but now it is just in 3 minutes you are able to machine that. So in turning, similarly the spindle is there, rotary job is placed in the spindle. There is a turret with a tool post on it, and tool holder with ISO inserts. ISO holder will be able to cut the part, that rotary parts. Here, because of the time limitation, maybe we may not be able to cover turning, so we'll be covering milling part of it, and then moving the question and answer sessions. Okay. So first of all, here I would like to use who all are using mastercam. So if we take a case of army base across India, they are all using mastercam. BARC, Baba Atomic Research Center, they are using mastercam. BDL, as I mentioned, Bharat Dynamics Limited. Then engineering colleges, many colleges across India. Bharat Electronics is using, C&W railway workshops are there across India. There are Chittaranjan railway workshop, DLW Varanasi is there. There are so many railway workshops which are using mastercam. Then TTF training centers are there. All training centers are using KGTTI. This is Karnataka, German. Then Government Institute of Technology, Department of Space, University, SVNIT. So all such PBG engineering college. So many colleges in University of Pune, almost in Pune especially, around 100 colleges are using mastercam. GTI is Gas Turbine Research Establishment, Bangalore. Then these are all different industries. ARI, Automotive Research Institute. CTTC Bhubaneswar, CTR Ludhiana, CITD Hyderabad, Indo-German Tulu Aurangabad, Ahmedabad, Indore, all Recently, we have implemented in almost 10 technology centers of Government of India across India, which are there in multiple cities like Pondicherry, Visakhapatnam, Kanpur, then Batti, or Rohtak. There is another center at Kanpur, and one near Sitarganj, which is in far part of Uttarakhand. So there are various institutes, various industries into Danish tool rooms. So recently we received the best partner of mastercam in India. So we got it awarded that trophy. This couple of our team members. So with this, what I would like to do, I will like to take the session to the actual certain features, how we can program. So Akash, my other colleague, will explain you that. And if you have any doubts, I will explain you personally on that feature. On the right hand side panel, you can ask the queries if you don't understand. So maybe at the end of session, then we will take one by one all questions and explain you. Even after that also, you have any other queries, I will definitely share my email ID with you, so you can definitely ask such queries, because some of you might be looking forward for doing certain projects in CAM, maybe machining of cavity of certain part, automotive part or something like that. So that such kind of a thing, if you want, we can do that. Okay, there are many multiple things, possibilities. I will hand over it to Akash. Akash.
Thank you, Nitin sir, and good morning to all of you. So, as you can see that first machining operation in mailing, so we have to do first face toolpath or facing operation. So this facing operation, we need some basic parameters. Okay. So what is face toolpath? Like in this toolpath, one can quickly clean the stock from the top of the part and create an even surface for future operation. You can pass the toolpath or either change geometry or on the current stock model. So there are some given basic parameters like across, along overlap, approach distance, exit distance, and step over. Similar to that, for the facing operation, you will get some uh, types of facing toolpath like zigzag, one dynamic, and one pass. This is the toolpath way. Okay, so given side there is a simulation video for the facing toolpath. You can see, and just playing that. Okay, this is our facing operation, and this toolpath is like a zigzag. Okay, so let me show you the mastercam interface 2020. As you can see, there is a model, existing model. On this existing model, I have to create facing operations. So first of all, for the facing operation, so we have to do first stock setup. Okay, for the stock setup, we have to go to the toolpath manager. In this toolpath manager, you will get properties, and in this properties, you have to set the stock setup. For the stock setup, we have to select the all entities, and after that, give the value of Z for the facing. Okay, I have given that and display that. After that, click on OK. After that, after OK, you will get the wireframe stock. Okay, this is our extra Z value 2 mm. And after that, go for the operation from 2D toolpaths. Here you will get so many of toolpaths like contour, drill, dynamic mill, facing, dynamic contour, pocket, wheel mill. There are various type of toolpath in 2D. Okay, so first face, after click on the face toolpath, you will get a window for the chain selection. Okay, here we will get so many type of method for the selection, and we have to select the chain. After selecting the chain, you have to click on that. Okay, and okay, and after that you will get a window of 2D toolpath fetching, and according to your application you have to select the toolpath type, which toolpath you are doing now. So I have to do fetching, so I have selected face, and from next we have to select the tool. In this tool you can see that there are various types of parameters like tool diameter, corner radius, tool name, tool offset, length offset, head, diameter offset. There are the various cutting parameters, tool parameters are there. Okay, according to your application you can given the value of tool parameters or cutting parameters. And in this comment box you can write anything to for the operator, like this for example I'm writing here that fetching with as for my tool that I am using that or I will use. Okay, so for the tool you have to go to the standard tool library. Go to the standard tool library, you have to click on this select library tool. After select library tool you will get there are a lot of tool. Okay, if you want to filter that you can also filter. So after selecting filter I just got a face tool of 50 diameter and click on OK, and you can modify also that. On the right click of the tool you will go for the edit tool, and here cutting you will get cutting diameter, secondary diameter, overall length, cutting length. Okay, and which type of corner type you have on your tool you can give also that. After that finish on that, and just in comment I have just writing that fetching with 50 mm tool. Okay, and coming to the next in holder, as for your facility or as for your availability of holder you can select the holder. Okay, I have selected BTC30016. And coming to the next parameters, in cutting parameters you will get the style that I have told you in PPT, that you will get there are 4 types of style like zigzag, 1x1 pass, dynamic. Okay, basically the most preferred is zigzag, preferable style is zigzag, and here we will get the across overlap, along overlap, approach distance, exit distance. Okay, and step over also. After that here you can see that climb and conventional like up milling and down milling. And after that if you want to stock to live on floors, then you can give that value or 0. Okay, after that coming to the depth of cuts, in depth of cuts you can provide your depth of cuts value, like I am just providing 0.5. After that keep tool done. If you are selecting this keep tool done, then your tool not repeated time for the retraction or clearance. Okay, and coming to the next in linking parameters, this is the most important parameters. So in the linking parameters you have to select clearance, you can give the value of clearance, and all you have to set in absolute. Fit plane it's okay with incremental, and depth also in absolute. Okay, so as you know that it automatically select the top of stock. As you know we have given the Z value +2, so it automatically generate that 2, and after that we have to select we have to just OK on this, and you will see the tool path here. Okay, this is our tool path, and this is our along overlap, this is our across overlap. Okay, so let me show you the 2D toolpath of this facing operation. Click on this back plot and you will get the 2D toolpath, how it generated, and play. Just see that how it cut that material for the facing toolpath. This is our 50% across overlap, this is a along overlap. Okay, and if you want to see in this 3D simulation window, then you have to go for this verify, and after the selecting this verify you will get another window for the simulation. You can see this is our 3D simulation window, and just decrease the motion of the tool, cutting tool, and in this window you will get so many informations like move ID, move type, and what type of operation that you are doing, and operation name, which type of tool that you are using. Okay, there are various type of information that you will get. Okay, this is our simulation window. Let me start the operation. As you can see, the tool is coming downward and cutting as per our given depth of cut, given style, the cutting method. So this is it our for the fashing operation. Okay, and if we are talking about the ANSI code generate, how it generate, then for the ANSI code generating, you just have to click on this post selected operation, that G1 on G1. Just click on this, and post processing you have to click on the ANSI file and OK. And after the OK, he will ask for the root where the file will be saved. Okay, and I just that will be on the desktop and save. After that, you will get a mastercam code expert window, or in this code expert window you will get your ANSI code, all the ANSI code as per your commit. You will get this. Just see. Okay, mail face pocket in. This is our all ANSI code generated. Okay, thank you. So coming to the next tool path is our pocket tool path. So basically, this tool path is used for the clean out material from enclosed boundary, using the specified depth of cut. So basically, this tool path is used for the roughing profile, and here similar to the tool path, there are some basic parameters like rough cutting methods, step over percentage, entry motions, and depth of cut, or linking parameters, etc. So as you can see, there is a simulation video for this pocket tool path. You can see the cutting method of this pocket tool path, how it will cut that material from the workpiece. Okay, so for this, just let me show you the mastercam interface with this pocket tool path. As you can see that here is a already existing material. On this existing material, I have to turn pocket. So for the pocket, I have to choose this pocket, and by selecting the chain, I have to select that chain, and at this time I have to remind that thing the arrow direction. Okay, so this is our toolbar type pocket. Coming to the next, in select library tool, suppose I have selected a flat end mill. Okay, according to your application you can provide your cutting parameters, tool parameters, and what is the holder, what is the cut parameters. You can, here you can see that stock to lever walls for the finishing purpose are. I just click on 00 because we don't need any finishing purpose. Okay, here, and here is the pocket types. You will get the pocket type standard facing. Come to the next, roughing. In this roughing you will get some cutting methods like zigzag. Okay, I just select parallel. This is a step over percentage or step over distance. Okay. Come to the next, this is the entry motion, how it will be entry. And come to the next, in finishing, if you want to do any finishing for the passes, you will provide, or you can provide that. And lead in lead out, this is not necessary. I will tell you about this lead in lead out, why we actually use that. And depth cuts 1 mm. Okay, keep tool down, linking parameters die, and clearance as per your requirement. Okay, top of stock already you have did that facing operation, and depth. For depth we have to select the depth or choose the depth. Okay, and okay, so as you can see, this is our 2D toolpath. Okay, just let me show you how it cut the material. As you can see, as per our given depth of cut value, it will cut that material. Okay, let me show you in 3D motion. So for the 3D, we have to go for this verify, and have to just start on play, and you can see how the material will be cut. Okay, so coming to the next operations is our contour operation. So for the contouring, we have to select the contour tool path. Here is the contour tool path, and by selecting chain, I have to select the channel for the contour operations. This is our chain. Okay, and after that you will get the same window. For the toolpath, you have to select the contour, and I've selected the same tool, flat end mill 10 diameter, and go for the cut parameters. Here you have to define compensation direction on which side that will be go. Okay, and here is the stock to leave on walls, stock to leave on floors, and go to the depth cuts. Okay, keep hold down. Lead in, lead out. Here this lead in, lead out is needed. Okay, and if you need any multi-passes, then you can also provide that. Coming to the next in linking parameters. Okay, just provide the value and depth. Okay, just see, because we did the cut parameters the right, and okay, so you will get the contour toolpath. So after that we will go for the next operations is our drill. So for the drill we have to select the drill 2D drill toolpath. Okay, and by selecting this mask on arc, we have to select just or find out the arc. Okay. After that, just drag on that and drop, and by selecting order you can define the order. Okay, same as it is. Go for the tool as per your diameter. If there are any availability, then it will be easily identified. You will get there are a lot of types of tool, and this is our drill. Okay, 10 diameter, that is availability of the 10 diameter drill tool. And go for the holder, select the holder, stock, non-edit, cut parameters, what type of cycle you want. I want if you want to pack drill, then just click on the pack drill and give the pack value. Okay, and go for the linking parameters. Active the clearance and retract, and go for the top of stock and depth. How much depth do you want? As you can see, this is our depth, so I just given that, and okay, this is my drill path is generated. And so Now I will show you the whole operations in a 3D simulations window. Okay, just click on it and regenerate all toolpath and go for the verify. And here you can stop condition. You can apply the stop condition by choosing the operation change, and you can also give the curl loop by operations and just start it. Just a minute, I didn't. Okay, now start. So first facing operation is done. Next is our pocket operation. Okay, and next operation is contour. Here you can see that in information. Okay, and next operation is our drill. Okay. So this is it, the whole operations. So how the NC codes will be generated? Okay. So for that you have to go to this post selected operation, that is G1 symbol, and click on that just, and click on the NC file and just click OK. After OK, you will get a window for saving file, the root file, root. Okay, after that just click on save, just replace it, that was my previous operations, and you will get a mastercam code export window, and here you will be able to find your ANSI codes. Here's the ANSI code generated. Okay, all the operation that you have done, you will get the all ANSI code very easily within a short time. Thank you.
So we just have a look at few important videos which will make you understand what kind of parts can machine. Yeah, so just here you can see that the entire flute link is being used for the cutting. Usually otherwise The depth of cuts are given in 0.51 millimeter or 0.1, 1.5, something like that. But because of the high efficiency machining, we are able to cut and utilize the entire fluid length of the cutter while cutting, and without any sort of what you can say efforts, the cutter is able to cut very smoothly a huge depth of cuts, and the parts are cut in a very short time. Let's show another one. And I'll show a couple of So these are all changes because of the newer technology available. Earlier this was not possible. The people who used to say that earlier we have got a lot of experience in machining, but with this a lot of changes, new changes, the old knowledge is almost absolute. Definitely that can be utilized by reshaping it or maybe updating it, for sure, because metal is metal and the cutter is a cutter. Here there is a tremendous kind of a changes, like 60% saving in the machining time and all. It's a huge. So with this, I would like to request you, whatever are your queries, please you can send it across on the right hand panel, so that I can address it to it. In mastercam, if you would have seen, there are huge number of toolpaths are many available, but with the time we are able to show you certain basic toolpaths. So in milling also there are 2D 3D milling machine, different toolpaths are available with the dynamic machining and all. In multi-axis, there is a good number of toolpaths specific to the impeller machining, hydraulic port machining. All such machining is possible and available, but with that time limitation, it was not possible. So we covered certain core part of it and try to explain you. In multi-axis especially, what happens is that user has to control the rotary axis, fourth and fifth axis, while third axis, XYZ axis is moving. So if normal XYZ is moving and you are controlling, means your stable is having moment, fixed moment in Cartesian coordinate XYZ. But when your rotary table moves, let us say A axis moved at 90 degree. So what happens? Your Z reference, X reference, Y reference is totally gone. So now machine has to understand. So there are RTCP concepts, Triori concepts, there are different concepts in order to have that tool center point oriented at a correct point. So there is a post processor which can help you get the output exactly required as per the machining requirement of that part. So even if you go 90 degree with the A axis and again rotate the C axis with the 360 degree or 180 degrees, you are able to machine properly. So here I could not see any query from you until now. Anybody has any query? Vijay sir has asked me one question while discussing before this starting of session. Like, what is the difference between the mastercam and the other cam software? Because those cam softwares are also available. Definitely, cam softwares are available, but the kind of ease available with the features, with the parameters, you can learn software very easily in a very short span, and then apply for actual programming and actual machining. There are softwares like which are CAD oriented software having multiple features, so they have tried to make it again complex manufacturing as well. So while learning that software itself will take a long time, may not be possible in the semester time frame what is available with you. Whereas if you take a case of mastercam, within the first 2-3 lectures itself you will be able to understand, start applying it, using it, and before the end of semester you should be able to apply it on the machines as well. So you don't remain in a stage of confused stage when you go out in the industry for the interviews. When they say yes I learned, have you applied? Oh, no sir. Why? Because it was too complex for us, so we understood it till the end of semesters. So that makes a lot of difference, because what happens is it is more important for you to learn, apply, and see in front of you. So when you talk to the interviewer at the time of interview, when he says that have you machined that, you should be able to confidently say yes I machined that, I use this cutter, I use that material, I use this much of depth of cut, I use this much of feed rate. So when it will come out of your mouth, when you have actually used it on the shop. While doing in a CAD CAM programming, you program it properly. So otherwise, when somebody asks you, yes I learned CAD CAM, I learned CAM programming. So what CAM programming you learn? So you will say that yes, you will draw one rectangle with one side corner radius, one half circle. So with mugging certain G codes and M code, you will say that yes, certain tool call command, coolant start command, spindle start command, then Z00, X0, Y0, Z10, and then type again the coordinate. So what exactly he is doing? He is doing the trigonometrical calculation which we do in 5th or 6th standard, and type those coordinates and write again certain GNM codes which are mugged up. So what technology you are learning? You are not learning technology, you are doing the trigonometrical calculation, writing it down. If Siemens are there, so you will write down certain Siemens related or Fanuc related, but you are not actually learning the technology. Technology is what? The strategies. When you have to do the roughing, so what type of tools you are using? So are you able to use ball nose cutter for finishing roughing? No, you need to use end mill flat cutters, or the cutters which are high fit cutters or bull nose cutters, because there you are able to give the better step over in order to cut the larger core areas or cavity areas, such areas, whereas the ball nose can be used only for the finishings. So there are lot many technological areas. Once you start using it, you will understand what is the difference between flat end mill, ball nose, taper end mills. So all that will happen when you are selecting a holder here. So what is BT30, what is BT40, what is BT60? So you have to, when you see that, you will have a query in mind. Why BT30 and why BT50? The machines with the very low forces are smaller machines. You will find the spindle with BT30, whereas larger machines will have a BT50, BT60s. So because there is a huge force which is required for the machining. So these queries will come to your mind when you will see that, try to apply that. Many times when an engineering drawing is put in front of a student and ask, so he has learned most of the GD&T symbols, but he is not able to make out properly. When certain things are required in concentricity or maybe a cylindricity or certain part while machining, or there is a N certain 3 symbol for surface finish given, so he is fully confused because he has not applied it, he has not used it. So students, if taught in a CAD class, design, GD&T, and then while he is going into the manufacturing class or CNC programming class, he should be able to read out the symbols which are given, whether there is a right angle required, where is the datum given, which are faces are required to be parallel to what. So all such things are very, very important. Somebody asks what kind of what size of drill you will use for M12. So he is blank because he has never used it. It's not that it's his mistake. Many a times I have seen a student when one reamer is shown, one drill is shown in front of him and one end will make a difference out of it. So he is again a blank. Reason, he has not actually used it. Sometimes they will say that now use this reamer for end milling. So he has to use it, then only it is possible. Here I think some as it is somebody as Ashish Prasad has given one. Is mastercam easy than Fusion 360 for CNC programming? Fusion 360 also has got features, but very limited features. So for basic learning, definitely you can use it. But when you want to acquire a knowledge which is at par with the industry, then mastercam has got such features which will help you learn the technology with the industry level, but with ease. It's not that it's too complex or too difficult for learning. Your BITS Goa is using it for learning. They are using that, as I mentioned, this backbroad engineering is there. NIT, so many NITs are using. IIT Mumbai is using. IIT Chennai is using. IIT Guwahati is using. So why they are using? All Indo-Germans, when they start after basic AutoCAD basic training, the first thing they do is that CNC programming with mastercam to make students aware of the CAD CAM with very ease and proper concepts. So that's a part of it. Like here Shanti ma'am has asked one query. Mastercam with CAD softwares like SolidWorks, CATIA, CNC machining that are with us. Yes, those softwares where whenever you do any CAD modeling, SolidWorks has got a direct translator. You can directly open the model within mastercam and you can do the programming. CATIA has got, from CATIA, while saving it, instead of saving CAT file, you just save step file or parasolid file, then you can immediately use it. There are optional direct translators which are available, but without that also you just save it as a step and you can use it seamlessly without any problem. So this was my this one. If at all you have any further queries, any information you want from me, definitely you can come back to me asking for anything. We do even certain MOUs with institutions to help students doing certain projects and undergo certain, even there is international certification available with mastercam. Students can learn mastercam. We will also give you this one, your registration to the mastercam University USA, and then you can apply for international certification, that is mastercam University certification, which is valid across the globe. Even if you go to Japan for any job, if you have that certification, that is valid. If you go to US or Europe, that is valid. So such kind of things are certifications which are the